Today I got Jared with me. Jared, how you doing?
Hey, I'm doing pretty good. How are you?
I'm really well. Hey, Jared, I'm detecting an accent. Where are you calling in from, please?
I'm based out of Atlanta.
Atlanta. I've been there 6 times. Stayed in a hotel opposite the Coca-Cola Museum. I enjoyed it every single time. Do you know the one?
I believe I do, yes.
Yeah, okay. It's a famous spot downtown. Anyway, this video is not about that, Jared. You've been on my list for some time. So I'm in marketing. You're an academic. I've been wanting someone to talk to everyone about synthetic control methods and how they're used, what we do with them, why data scientists reach for them. So I'd love to go through that with you today. But before we get into it, perhaps an intro, please. Would you take a minute and tell everyone what you've been doing?
Yeah, so I'm Jared. I'm currently a PhD student of public policy at Georgia State University. Um, Lots of my work is in econometrics and causal inference. Specifically, lots of it, deals with, the synthetic control method, how it can be used for, policy analysis, but also increasingly in the coming weeks, certainly, for marketing applications and ad campaign analysis and that sort of thing.
Good. Well, this was my way in. So showing ads to people, but needing to understand the effect. So why don't we jump into like just the definitions? How do you, when you're out at dinner or something, Jared, and you missed the part that you developed a package for this. So, you're a coder and you built a package so that the rest of the world can partly benefit from this method. But how do you describe it when you meet some random person and they say, Jared, tell me about synthetic control methods? How would you explain it?
Yeah, so, I usually find that giving simple examples is actually a lot easier for people, not just like who are technical, but like normal people to understand, right? So, for example, let's say that there's like a city, right? And the city does some anti-crime policy. Let's just say it's, I don't know, New Orleans or something, right? Well, we can compare New Orleans to other cities that maybe haven't done a similar anti-crime policy, like say Miami or Honolulu or Atlanta, or Memphis, or other areas, right? And synthetic control is basically it's a really simple, sort of idea. It's basically this idea that, okay, we think some things are more similar to each other than other things, you know. So because we believe that, because we think, one thing may be more similar to New Orleans or any unit, right, than something else, we go, okay, we want to have an estimator that accounts for that in some sense, that says, okay, if only maybe 3 or 4 or 10 or whatever the number of these cities are actually like useful for comparison purposes, we're only going to use those, some weighted average of those, as a proxy for the counterfactual, or how crime or whatever metric, whatever KPI that we're interested in would have looked had that intervention not happened. It's basically this idea that we want to know the counterfactual. We want to know how a metric would look, absent treatment. So instead of saying, okay, all these places are probably equally comparable, we're going to say, okay, maybe only some subset of these units are comparable. And that's, that's sort of how it works. It's just this sort of weighted, sort of comparison based, kind of estimator where some places or units are allowed to matter more than others.
Good, thanks for that. So interesting, you picked up on the cities. So I think a lot of marketers would have seen geo testing and these sorts of concepts. So when they're doing media, they're kind of like, hey, we're going to hit Georgia with all of this campaign activity, and forgive my geography, Louisiana. Where's New Orleans? Louisiana, yeah, something like this.
Yeah.
So some other state has a different bunch of treatments, or nothing.
Mm-hmm.
You want to demonstrate the differences. Jared, what other applications for the marketers can you think of?
So the main utility, as far as I understand, at least, that marketers have with synthetic control, at least from the campaign analysis angle, right, is mainly that, right? Like, okay, we're gonna advertise, say, in like 5 markets or 10 markets or whatever the number is, right? We can basically construct a synthetic control for each of those, kinds of markets. So there are obviously different ways that we can do that, right? There are ways, so let's say that the 10 treated units are already chosen and they've already been treated, for example. We can construct, separate, counterfactuals for each of those, and then maybe average their effect sizes, different ways that we can do that. But another way that's also really interesting that people have been focusing a lot on recently is using synthetic controls for the design of market experiments, right? So in other words, suppose, I don't know, in the US, we have like 300 markets, I think, roughly. And we say, okay, we want to do this new intervention, right? But we want to know what the impact of the intervention would be like in the broader, market, as opposed to like, oh, there's just this one area, right? What we can do is we can use algorithms, optimization algorithms to choose who should be treated and who should not be treated. In other words, we can construct a kind of market, experiment without randomization that gives us, synthetic treated, units and synthetic control units, right? That basically make the treated, group look as similar as possible, right, to the broader overall market in the pre-treatment period. So the main applications that I see for them, at least, aside from studying what we already, policies that have already happened, is using synthetic controls to basically design, geo experiments that people can use for whatever policy or intervention that they wish to use it for.
Got it. No, I like the treated one. So you can scale to build a control group. So you want to see this parallel universe. We want to see these units, like who did we not treat, but they look similar enough. You reverse it the other way around. Say, well, actually, we want to pick some synthetic treated, and we want to be able to scale it so it looks like the US population or looks like something else. Yeah, I got it right. So this works both ways around. That's really cool. So back onto the marketing ones. I've met this a few times over my life. So I've seen the ad one, which is always, for anyone watching, it's kind of like, you're doing something that week. Customer wanders onto your website, sees something special that's either unique in a marketing context or it's time bound. It was only there for those 7 days, but we need to figure out, did it create a behavior change or did it do something else? The synthetic control is useful for like grabbing a whole bunch of customers that share all those characteristics of those visitors. I suppose there's one difference, did not visit the website that week versus those that did, but everything else is as similar as possible. And from there, you can kind of do your normal ROI things and these sorts of bits. Jared, I've seen the retail ones. So it's like store clustering is sometimes how it's called. So it's kind of like trying to put retail premises together into buckets. So like, hey, we altered the layout of some stores over here.
Yeah.
Like we've got 500 stores nationally. Like, can we reach into the other 497 and try and pick a bunch that share the footfall, square footage, product ranging sales, the right distributions of product sales and all these sorts of things.
The average basket size or, stuff like that. Yeah.
All of that.
Yeah. Like the idea that like, okay, we added some new cool, not feature, but some store layout, some sort of difference in the way the store is like physically presented. Like, does this affect sales in this department versus something else? Yeah.
So we got into the features there of like a store, distribution of their products, where they are in the cities, and all these kind of things. So take us into the detail of this. Imagine I'm sitting there with Python code, quite a common event. What would I be doing if I was with your package? Like trying to build myself a synthetic control? Like, what are some of the inputs? What things can I tune? What things can I take control of with what you've built?
Yeah, so for MLSynth, my Python library, it's a really versatile, sort of ecosystem, so to speak. I don't remember the exact number. It has like 25 or maybe a little bit more sort of distinct, kind of synthetic control style estimators. All of them obviously have different use cases. We could probably do an entire show about some of those by themselves, right? But the main sort of philosophy that I take as sort of the approach to developing the library is I want the experience for the user to be extremely simple. In many cases, in whether I look at stuff in R or Stata or sometimes Python, I find that lots of the existing implementations of these kind of synthetic control methodologies, they require the user to do lots and lots of legwork that is probably very tedious or that they don't necessarily want to do, all the time. So the way that I designed MLSynth, at least, is sort of to simplify and streamline the implementation of these models. At the very simplest, all the user needs for one is a long pandas data frame. I know at some point maybe I'll allow them to use polars or something, but for the moment it's pandas. And all they need is a column that identifies the unit, so a string, a column that identifies time, whether it's an actual date time, object or like an integer, a year, something like that. They need the outcome of interest, obviously it has to be numeric, over time, panel data structure. And they also just need a simple flag for the treatment. So that is, let's say it's a market that's treated, I don't know, on February 18th or something, right? The treatment variable has to be equal to 1 for the actual treated unit from February 18th all the way forward, right? In most cases, at least for MLSynth, 0 everywhere else, right? And then under the hood, I've went through very great pains to do the it's like a totally separate API, like internally, for like all the data organization and reshaping and labeling and so on and so forth. So then anyway, from there, once you know what your treated units are and you have those 4 simple sort of criteria, at that point all you have to do is pick whatever class from MLSynth would be most useful to your particular problem. You run the results, and pretty much for every class of interest. Although this, I still have to make some changes, but basically what you'll get across every single class at the moment is you'll get the fit statistics, the ATT, you'll get the observed versus the prediction. Am I missing anything? Of course you'll get the weights. If the method uses weights, which is pretty much all of them. And then from there you can calculate your iROASes and all the other fun marketing sort of metrics that that people care about. It's really, really simple. The main thing I think that it comes down to for the user at least is which class do I want to use, and usually in most cases which set of these options make the most sense for me to use. So I don't know, it's really meant to be user friendly in that sense. The user is not at all intended, unless they want to, of course, to work with the underlying details of CVXPy or anything like that under the hood.
You've saved them, Jared. Answer this question for me. So I work somewhere where we were working with transaction data. So we had this rich data set. You're looking for like, hey, people are spending money. At a certain point in time, the intervention starts, and we were, building a synthetic control to, capture the people that didn't get the ad. It was that type of thing. Mm-hmm. What's the role of pre-period kind of transaction or time series data in the pre-period? Is that something that users sort of would have to pre-prepare themselves, or does MLSynth have some capabilities in this area? So basically, let me make sure the period is the same.
So let me make sure I'm understanding. Like, what's the outcome here?
Well, we're trying to still as before. We're trying to look for in a post. You've got to date the intervention started, and we're trying to compare exposed versus control.
Yeah.
What we wanted to check is when you've got a column before, it sounded like you've got a column with what is the unit, something that describes it. How would you insert like time series features to make sure when you pick the control, can you do it over categorical variables and time series inputs via the package, or would you have to kind of prepare the data frame yourself?
Yeah, so if I understand the question well, like so the key thing, and I think this is one of the main innovations, at least with respect to some of the other existing libraries out there, right? Is that the control group is completely chosen based off of the treatment flag. Like under the hood, what'll happen is it'll check, like, actually here's literally what it does, right? It basically converts, it flips everything to wide, so each column is a unit and each row is a time period. And then it checks to see, okay, which of these columns, for their, for the treatment, variable are ever equal to 1, right? And then basically what it does, it says, okay, this only one column has, a 1 assigned for the treatment. So that now is our treated unit. And everything else that's not, that where the treatment column is not equal to 1 or never equals 1 is the control group, right? And then from that point, what actually happens, which it's actually really helpful. I basically have developed like a data prep class, right? Or no, I'm sorry, a data prep method. And basically what it returns is just gives you a dictionary. It just gives you a dictionary that says, okay, this is the treated vector, right? Everything else is the outcome, the outcome of interest for all the control units, the donor, of the donor matrix. And then you get, all the other stuff. You get like the list of the names of the control units themselves, which is really helpful when you want to extract the weights later on. And you also get the number of pre-intervention and post-intervention sort of time periods. So just if this answers the question, the only thing the user has to do, I don't expect the user to do any kind of data cleaning. Well, aside from like organizing it in the appropriate format for the analysis, right? But aside from the most basic forms of data cleaning, all you need is a long panel data set where each row corresponds to 1 unit in 1 time period.
That's the answer, Jared. Great. So it handles the time series elements, because this is something like I've kind of seen the version where a synthetic control is picked based on customer characteristics, for example. So you'd be like, okay, I have the right mix of age and affluence. And then what we go off and do is some other exercise to check pre-period spending pattern or something else. The time series is like a 2-step approach. So ML Synth allows you insert the whole panel. It does everything for you. And at the end, you walk away like a rock star with a synthetic control group that handles whatever was in the data frame is pre-prepared for you.
The only exception I would say for that is that the vast majority of, I can think of like some exceptions, but like the vast majority of the classes in ML Synth do not use like additional background covariates. So let's say that the outcome is like foot traffic or something, right? At the moment, most of the classes do not allow you to say input demographic, characteristics to match on or other sort of things. Not because I don't think that those are valuable, not because I don't think that those can ever, have some kind of use, but mainly because it's a lot of work once you start, like incorporating additional covariates. And plus, in many cases, they're not necessary, right? Not they're not useful, just they're not. It's just that they are usually not necessary to attain, good, quality sort of pre-intervention, in sample, sort of fit. But at some point, I think that'll change. I think at some point, for the vast majority of methods, I'll probably allow users to say, okay, if you have these additional covariates, fine, you can incorporate their averages or, that sort of thing. At present, it doesn't allow you to do that, but that also, in principle, is one thing that one could do if they wanted to.
Yeah, I think the case for that I've seen is sometimes, and thankfully I didn't work on many of these, sometimes you have in the marketing side, you have like loyalty propositions where you have this kind of thing of like, hey, it's loyalty, and there's this certain profile of consumer that just loves this stuff.
Yeah.
And then there's just everybody else. And on every, you call a covariate, it's just like an attribute relating to the customer. On every dimension, they're kind of different. And you're having to search within this non-loyalty membership base to try and sort of triangulate this group that will be like, everything about them looks like they should kind of be in, but they don't receive all the benefits. You finally can produce analytics this way feels really good to do it because you're like, right, I'm really working with the data now to try and prove this point.
Mm-hmm.
You reach the end of the road, and it's kind of like what's not there is the hidden covariate, which is the consumer's attitude towards like, I
Yeah.
just like saving money, or this is my brand. Like there is not a data point for this.
Yeah, these
So
unobserved sort of like characteristics. Yeah.
yeah. So this would be the case of like if you had tons of different covariates on consumers, the loyalty self-selection bias problem would be a good one there. Well, Jared, thanks for taking us through all this. Before we move off synthetic control matching, what's like the what doesn't this do? Like what are some cases where this doesn't work well, or what are like the painful pieces of it? What would be some cases where you kind of don't know would recommend something else or don't recommend it?
Yeah, so synthetic control, it's most of the work that I do, but it's just one tool and a very massive toolkit that econometricians have provided us over the years. Lots of the caveats that some people will say, and I don't think this is accurate, at least not anymore, right? Is well, you can only use it when you have one unit or a few treated units. No. By now, we have enough mature, sort of estimators that allow us to incorporate multiple treated units over time, right? Now, of course, that's a much hairier sort of question because you do have, staggered adoption, that sort of thing. But there have been plenty of, sort of innovation with not just synthetic controls, but synthetic differences that allows us to say, okay, well, what if we have different, sort of number of treated units over time? That's something that we can readily tackle. The main challenge, I think, that people, I presume, are working on, right, is how do we do this? How do we even think about doing this when the treatment sort of switches on and off, right? Like, let's say that we have a promotion, I don't know, for the first 3 weeks of the year, right? Just for example, right? But then, I don't know, 5 weeks later, we turn on the exact same promotion. I'm not even sure what that objective function would look like, right? I know, for example, that differences, if I remember correctly, large as the literature is now, I don't think synthetic control, at least yet, can do that. Like, what if the treatment comes and goes, right? How would that work then? The other thing, at least from a computational perspective, is synthetic control is mainly justified within a setting where we have relatively a few treated units. If once you start getting into, like, say 1,000 or 100 or something like that, you can make a better case for methods like differences or sort of other kinds of methods, because you basically would only have to solve one sort of optimization instead of 1,000 in theory, at least, right? But beyond that, I think the decision to use synthetic control should always be predicated on just sort of the assumptions. Can you get good sort of pre-treatment fit, right? Are we using a modeling strategy that allows us to account for level differences between the treated unit and the control units? Is there something else, like, let's say that there's like a running variable, kind of a threshold that we can use to sort of, think about this. Well, then we can use regression discontinuity, and we don't have to look at synthetic control, right? So I don't know, the best advice that I think I can give, sort of to practitioners, myself included, of course, is whenever you make a decision to use a modeling technique or strategy, you always have to evaluate it, implicitly against the other options that you have available, your randomized control trial, instrumental variables, so on and so forth, right? And then if one or a few of those modeling strategies meet whatever criteria that you have, well, then you go and do that, right? But beyond that, I would say one of the key sort of areas that we're still working on is multiple treatment units and what happens when the treatment comes and goes. I don't think there's really been a really good answer for that just yet. But I'm sure very smart people, probably at Columbia or MIT, will develop some sort of solution over the next couple of years for that.
Yeah, Jared, it exists in the marketing world, at least the second one. So the treatment that comes and goes, sometimes this is like a tech problem with how do you deliver an experiment. So the one people might recognize is like web teams in big brands. They're obsessed with conversion rate optimization, experimentation on their websites, but you have the equivalent, the issue of identifying users consistently. So sometimes it's visitor based. So one day a visitor can see version A of a website, the next day by accident they see version B, which is flip flopping between the two. So they're getting some of the users are getting multiple exposures. And then if the web people are on this call, they'll be saying, yeah, well, John, there's different browsers and devices and the attribution tracking breaks. So there's this whole messy world that thankfully I don't have to get involved in. And just on one thing you said, Jared, I can't believe we missed it. Synthetic control for me, at least, was something I always think of is marketers are familiar with the randomized control trial. This is going to be my experiment. Synthetic control, when I first started coming onto my radar, was super useful because it's like, aha, this is something that when it's just not possible to do that. So when it concerns like sort of media or there's less control over how this marketing thing is delivered, it gives us this way of measuring it. There is a third one as well, Jared, which is marketers did something, never came and told the analysts. So look out for all the comments coming back at me for that. But it just is sometimes more not to have an argument with the marketers. More like business goes fast. Yeah, it's not always possible to just kind of like figure every single thing out ahead of time. So
it's funny, like, coming from academia at least, right? Like in the world I exist in and have existed in for most of my adult life now, right? Most of the treatments that we care about just can't be randomized at all. It's not possible, right? We can't coin flip, public policy or earthquakes or other kinds of things that we want to look at the effect of. So certainly coming into the business, to the private sector, where we relatively have more control over the interventions that we care about, but not all the time, of course. It really sort of opened my eyes as to like, oh wow, like quasi-experimental design, in some sense is, sort of what the new kid on the block, so to speak. I mean, not entirely, of course. Your Metas and everyone else have a long track record of this, but it's just really, really interesting, in other words, to see like how different methodological traditions can be in one ecosystem where you have relatively more control over the treatment assignment mechanism versus in public policy and econ, where you basically have none in most cases that we care about.
Yeah. It's a complex world, Jared, and the world is lucky to have you. So look, good luck with your studies. Congrats on building the package. Thanks for sparing the time to come and talk to me on this topic today. I've been wanting someone to do this for ages. Ladies and gents, this was ML's Like Teen Spirit.